Or do you want to talk me through roughly how it's meant
Yeah,
to?
so this for this particular project, what we did is there was it was a city council chamber. So there was a section of 19 total microphones who basically wanted to have preset recalls to hit each, either pair of chairs or three of chairs,
Yeah.
depending what was happening. And they're kind of in like a U-shape sort of configuration. So they're coming from not only different camera angles, but also different camera PTZ positions.
Yeah.
So the whole general sense of this is that you can take something simple as a signal presence light that could come from, a mix down of multiple channels or channels themselves, and be able to basically fire presets off of that based upon who is doing the most amount of talking at the time, or be able to make changes like that. So that if two people were having a conversation, it wouldn't just rapidly flip back and forth. It would sort of basically count up a number that would basically transfer back and forth between them. So in a conversation like between the two of us right here, if I was talking right now and stopped talking, a counter would count the number would decrease, and as you replied to me, the number would increase on your signal present input, and then that would cause things to happen on the other side to flip around.
Okay. So at some point you hit a threshold and then, yeah.
Yeah. So basically, and if we go into the code here, you can see amongst my spelling errors that I just noticed that there's basically at the top, we basically set a variable and set a value to them. And basically a couple other variables which set sort of some of the more fine detail tuning controls, like that HTP number is basically the number that it'll count up to. So every time it counts, it will add up until that number. The add number is how much it increases, and the subtract number is how much it decreases. So like if I was talking right now and I stopped talking, I would probably want the number to drop faster than I would as it was adding, if that makes sense.
Yeah, a little bit. I'm reminded of things like the the parameters that we have on gates. So your sort of hold time and release time, attack time on a gate.
Yeah, and basically the add and subtract, or basically, so I think, and if you go down to the bottom of the code, I think it'll actually have how many times or how often the timer ticks. But yeah,
twice a
so yeah, basically every half second. So the add number is actually how much value it adds to each input to be able to say, like, so instead it could add 1 or 2 or 5 or 15 depending on what numbers you were using to be able. And then so what's a better way to say this? So for if the present to signal presence light was on and you started talking, every half second it saw that signal present light, it would add 1 to the number, okay, to the basically its value number. And in each time you didn't talk, it would subtract 2 potentially, so that it would drop faster than it would add. Does that make sense?
Yeah.
So that was kind of why I did it that way, because I wanted the number of that camera value to drop faster than it was added, than it added to it. Yeah, so I don't know if we want to go back up towards the top, but basically each timer, and there's probably a much more efficient way to do this, but each timer tick for each one of these timers, if you scroll down just a little bit, we'll basically see if that present light is on, and it's not above the value that we've set as our like top number or whatever, it'll add a number, right? And then there's a function down at the bottom, which I think it's set as 3 or 4 seconds. It'll basically look at all the different variables that are and put them in an array and say which one is the highest number. And if that highest number is there, it'll fire an indicator light on the output side.
Okay, and it does that every 4 seconds.
Yeah, I think that this one's set up as 4 seconds. And I might have made some small changes to that, but I didn't want camera changes to be happening super rapidly. I wanted them to kind of have a more kind of like timed event there, so that if someone so that it's just not flipping around all of the time, but also fast enough that if someone else starts talking, it flips relatively quickly.
Well, maybe we'll start with just so there's kind of some patterns you can apply to kind of simplify it without even getting too much into how it works or adjusting how it works. So one of the things I look for when I'm writing code is repetition. But generally, if I'm doing anything more than twice, would be the absolute maximum. I would try and find a way to write that code once and just call it multiple times, either in a loop or using a table. So, for example, probably the easiest way to start with that is down here in the timer compare.
Sure.
I may just tweak the indentation a little bit as well. So just for a bit of readability. So just by indenting like that, you can kind of follow which arguments are feeding into what function. The other thing I would say just here is it's worth, wherever you don't need a variable, like here we don't need x outside of this function, I'd suggest making it a local variable and kind of using local variables by default, except for things that you want to be global. Because if you use a variable in one part of the code, like x, that's just a throwaway thing, and in another part of the code you use x and you assume that that is going to start out being empty, then that may prove not to be the case if your other code has already run, because they're all sharing the same variable space. So by making it local, x will only exist inside this function, and as soon as we hit end, x disappears. The second thing I would say is there is a built-in math.max function. It should tell us expects some number of parameters or an arbitrary number of parameters or arguments, and it will return the highest of those. So we can just return those, and that will give us the maximum out of those. Next thing I'll do is seeing the repetition through here, and also given that we might want to change the number of presets that we have, I would say for I equals 1 to the number of preset controls. So starting at 1 and ending at the number of control presets. We otherwise could do, for I equals 1 to 9, but we're just subbing that out so that if we change the number of presets, it will change dynamically. And I'll leave these down here and I'll just sort of copy them into here. We can say if the brackets are unnecessary, that's just by programming style. If x is equal to I, then controls preset I dot boolean equals true. I'm just sort of copying it as we have it. Else controls dot preset I boolean equals false and end. And you'll have to forgive me the semicolons as well, because that's I use too many other programming languages that get angry if you don't use semicolons. So I'm in the habit of putting those in, and Lua doesn't care if they're there or not.
Understood.
So that way, we're no longer limited to 9 presets, and we've eliminated that repetition. So if there is something we need to change in the logic here, we only have to change it in one place. And we can kind of repeat that pattern through the rest of it. The next thing I'm spotting looking at here is we still have a bit of repetition in here, in that we say if x equals I, then control that boolean equals true, otherwise the boolean equals false. But x equals I, if that's true, if they are equal, then this will be true, and we put true into here. whereas if it's false, we put false into here. So effectively, we're just putting the result of x equals I into .boolean. Does that make sense?
Yeah, I think so.
So we can just say, for each control, if x is equal to I, then the Boolean is true. The result of that comparison is whether or not it's true.
I get it. Yeah, that makes sense.
And we can probably remove the print statement, so that timer compare function gets quite a bit simpler.
Yeah, way simpler.
So the next thing I would look at is our timer functions. I think rather than having a timer per input, we could just have one timer that runs that often, and within that timer we check each one. Because that's sort of functionally equivalent. If we're doing 9 things twice a second each, then at that twice a second frequency, we could just do those 9 things in one function rather than in 9 separate functions.
Right.
So if we take one of these functions, and we'll call this something descriptive like input presence timer function. So say again for I equals 1 to the number of controls. In this case, we're doing present. There isn't much difference between these two syntaxes, by the way, controls.present and controls brackets present. Other than that, the brackets will let you do things like put spaces in here.
Right.
That obviously you couldn't with a dot. So the dot is just it's what we call syntactic sugar. It's a little linguistic shortcut for saying the same thing a bit quicker. So we've made our loop there for the number of controls, the number of present controls, and we can say, so here we run into an issue because our camera values are all in separate variables. We don't have something that we can just index into with I. So what I'm going to do is just say cam values equals empty array or empty table, and then say for, just as the program starts, for I from 1 to the number of controls present, do cam values I equals 0. So that's just built a table of zeros, effectively. It's the same as putting 9 zeros in here.
Right.
But that means that to access the value for a specific camera, we can just use this syntax cam values I, which means that I can be a parameter from a for loop. Does that make sense?
Yeah, for sure. So basically you're just creating, instead of establishing a bunch of variables, you're basically creating a table of variables.
Yes, exactly.
Or an array, rather.
Yeah, table would be more correct in Lua.
Okay.
So any kind of structure in Lua is a table. It's just that tables can kind of pretend to be arrays. So in a Lua table, if we're defining one, we can say 1, 2, 3, and that's a table with 3 elements in it. Or a better example actually would be A, B, C. And we'd say this is the first element, so we get to that with x1,
right.
And so on. But again, this is actually more of that, what they call syntactic sugar, for this. So 1 is A, 2 is B, 3 is C. Right. That happens automatically in the background. If you don't specify a name for that part of the table, what we call a key, then it will automatically give it a numeric key. So we could say, apple equals A, 2 is 3, and then we could say print x.apple, and we would get A.
Okay.
Numeric keys are the default, and they're put in for us. And if we just use numeric keys in a table and nothing else, then it acts like an array in other languages.
Got it.
Yeah. So now we have our camera values in the array. We can say if we call it cam values I is less than HTTP, then cam values I equals cam values I plus add. And you know about string concatenation? So yep. Cool. And then the else case. So one thing I've just spotted already is that the camera value can actually go above HTTP and below 0 if add and subtract are bigger than.
That's a good point. Yeah, I didn't think about that.
Yeah, so if HTTP was 4 and camera value was currently 3 and add was 2, it'll be less than HTTP, so this will run, but that'll bring it to 5. So I think we might come back to that in a moment and fix that. So that becomes our timer function for all of these. And we're no longer using our max function because we're using the built-in math.max. And I'm a big fan of copying and pasting function names.
Sure.
Make sure you get the spelling right.
Cuts down on typos.
Cool. So that's our present timer there, and I'll just tweak the indentation on that while we're here. Cool. All right, so we want to fix that add and subtract limit, and also you can probably see, and this is part of why I start with indentation, is if your indentation is consistent, then you'll start to see, I have done something wrong there. Missed and controls present.boolean. Well, partly if your indentation's right, then you'll spot mistakes like that. Because I wasn't checking whether the presence was there or not.
Right.
Yep. But you'll see repetition just without even reading the code. You can kind of see that this and this are the same shape, which implies that there's probably a more succinct way of saying that. So if we look at the differences between these, the first is whether we're adding or subtracting, but then we're still printing the if debug boolean. So one thing is we could move this debug outside of this if else potentially.
Yeah, a lot of that was really just because when I was trying to figure out how exactly to do this, I was getting just a crazy amount of debug because I was trying to print all these values of all of these functions to sort of figure it out. And it's really not even necessary for the function of the code. I just wanted to have something that I could go back and look at, if I needed to.
Yep. So the things that are changing really are how much we're adding, whether it's the add or the subtract, and our limit here. So I think rather than doing this with branches, as in the ifs, I think we could do it with expressions. Expression, but yeah. So we could say the amount we're adding is, and this is Lua's ternary syntax. So controls present boolean and add, or 0 minus subtract, because subtract is, I assume, a positive number that we're subtracting.
So can you explain to me what we're doing with this?
So this and or is the quickest way in Lua to get the equivalent of what's called a ternary operator, which is probably best demonstrated in another language very quickly. I'll just pull up a JavaScript shell here. Does that come through?
Yep, got it.
Great. So in JavaScript, this is the syntax that we use for what's called a ternary expression. So it's saying check if x is true or false. If it's true, return this. If it's false, return this. This could be any three values here. So in this case, it says x is not defined. So we'll say x equals false. So we get 2. We get the alternative. If we say x equals true, the same expression gives us 1. And equally these could be. I don't know why I always default to fruit for examples. But because x is true, we get the first one, apple. Because if we set x to false, the same expression gives us banana. So it's just a way of turning a Boolean into 2 different values.
That makes sense.
Yes. So looking at Lua logic, Lua uses I've forgotten the term for it, but it's a kind of lazy evaluation of logic. So if we want to establish whether a condition is true that involves an and, we have to, if we look at the first part of it, if this is false and we're evaluating false and something, there's no point looking at the other side of it because both sides have to be true. So as soon as we know the first side is false, we don't bother checking the second. But if it is true, we do have to check the second. So in our case, we say this and this. So if the Boolean is true, we are going to look at this side. And so we're now looking at add. And then we hit an or. But because this is true, we don't need or anything else. We've already got a true. And so we just return this add. So if Boolean is true, we get the add. If this is false, there's no point checking the and so we never look at add. Instead, we look at the or, and it will return whatever the or is. So effectively, it gives us a ternary operator, but it is leveraging Lua's lazy evaluation of logic.
Got it. So the and the or are basically taking a replace of the question mark in that JavaScript example.
Yes, and the question mark and the colon.
Got it.
Basically become the and the or. So
then the 0 minus subtract is basically just turning that into a negative number.
Yes, exactly. So this way, the only operation we need to do to cam values I is just add the result of this expression. So now we want to make sure that it hasn't gone above HTTP or below 0. So we could do that with ifs. I've got a typo there. So we could just say, if it's less than 0, set it to 0.
Got it.
And we could say if it's greater than HTTP, set it to HTTP. And I kind of like this. You could wrap the addition operation in an if statement as you did, and I think that's a perfectly valid way to do it. The reason I like this slightly more is that you can kind of separate what part of the logic you're thinking about at a time. So looking at this chunk, it's just about calculating what the value would be, and then separately we can worry about constraining it as kind of a separate concern, if that makes sense.
Yeah.
And I'm always trying to look for ways to be thinking about less of the code at a time as possible.
Sure.
So that's our presence function, our timer compare, and our enable. Cool. And I think the only other thing I would do is bring these variable definitions into the timer function, just so that you can change those after the script has started. Because otherwise, when that...
Oh, okay. Yeah, okay. That makes sense.
So when that runs out there, the result will get stored in HTTP, and then it'll never be checked again. And because we're just using those in here, we'll make them local. And I would normally, just as a way to, as you're reading through, tell the difference between global variables and local variables, you normally start local variables with a lowercase.
Sure.
But
we need to change on that line 29. Will we need to change the name of that variable then, since they'll now be the same?
Yes. Yeah. Change perhaps, because it may not be an addition, or we could, just put that there. But I feel like that line is then getting a little bit hard to read.
Sure.
So I think that's all of our logic. We'll eliminate some white space. Well, this is the last bit we've got. We've got all the old chem1, chem2 values and so on.
Mm-hmm.
Now, math.max expects all of those things to come in as separate arguments to the function. So if we just give it chem values, it's going to see that as one table, and it's going to look for the biggest table out of the ones it's been given, and it's only been given one. It'll just give us back the table. It'll probably more likely tell us it doesn't know how to compare tables. So there's a function for this, which is table.unpack. And what that does is it takes the values in a numerically keyed table and pulls them out and returns them as if they were arguments to whatever function you're calling. So we'll just emulate this.
Say that one more time with the table unpack, sorry.
Sure. So table unpack takes the keyed values in a table, so the numerically keyed ones, so 1, 2, 3, 4, and so on, and pulls those out and presents them to this function, math.max, as if they were separate arguments. So as if we've done chem values 1, chem values 2,
Got it.
and so on.
Yeah, I had found that math.max function before, but I was never able to get it to work with things in a table, and I guess that's why. Perfect.
Yeah. So what do we have in terms of errors? Let's have a look. So line 29, we've got an attempt to compare nil with number. Because we've changed the name of HTTP. So this HTTP is not set as nil, and so it's saying we're trying to compare this number 0 with nil. All right, and we don't have any errors there. So perhaps I'll drop in some momentary buttons to trigger these, just for testing, I mean.
Yeah, that's how I tested it before. I think I actually did toggles just so that I could turn them on and off or whatever, but that's perfect. Yeah.
Cool. And I'll just save a copy of this just in downloads. Okay. All right, we have another error. Yes, okay, so we've got one more timer for the compare function. Yep. So the other thing I'd probably do is, because we've just got one function to run for this timer, I'd move the timer code up with the function that it's running. Again, just to kind of group logically similar concerns. So we can just say the present timer.eventhandler equals this function that we no longer have to give a name to. And then down here we can start that. And then here we can say our compare timer is a new timer. That runs that function. And then we start and stop it with the enable button. Check that. Yep. So what's our... Okay, and we're just going to whichever has the highest number, so there isn't an absolute threshold. Let's just, because we're not running sort of crazily often, I think one of the best ways we can see what's going on is if we just add an indicator per input, and then we can just print out the current value for that camera into that text field. Does that make sense?
Yeah, that makes a lot of sense.
Cool.
That's better than trying to cipher it out from the debug screen below it with 1,000 debug prints.
Yeah. So I'll just add a new timer key, and there may be a logical place in the code that we might put this, but still do for a quick solution. Say for I print a number of controls dot present. Missed a, and to start the timer. All right, so you can see they're all 0. If we touch the first one, I haven't seen that go up yet. So let's have a look. Our add value is positive, isn't it? Yep, 1 and 2. Controls present. Okay. So this should be controls present I to reference the correct present. That's one of those ones that won't give you an error.
Oh, that makes sense.
Yeah, because it's looking for, we've got 9 controls and we should be looking for 1, 2, 3, 4, 5, 6, 7, 8, 9.
Right.
Instead, we're looking for one called Boolean, which isn't there. And so it just returns nil and compares that and then carries on as if it was the value we wanted. Cool. So you can see that going up and coming back down. And we didn't see the compare timer. We can print out text there, it's fine. And I'm just going to split the screen here. Yep. That would do it. Okay, so we can see that number 1's come on. We'll turn on number 2, and then it presumably won't switch for a moment. Yes, okay. Yeah, so I've got the logic slightly wrong here. So, so math.max is not returning which of the cameras has the highest value. It's just returning the highest value, which is not quite what we want. We want...
Oh, it's returning the actual value and not the index number of the value.
Yes. What do you want to do in the case where there are 2 cameras with the same value? Does it matter which one it goes to?
I never actually considered what would happen if they started. Like, I mean, if you think about it from an application basis, the chances of 2 people talking for the exact same amount of time never actually occurred to me. So there wasn't necessarily anything set for that.
It should only be a very transient condition. So I think it probably doesn't matter too much which side of that we fall. So I would start by saying, so we won't use math.max because that's just giving us the value. We want to find which of the cameras is best. So we'll start by assuming that it's the first one, because we've got to start with some kind of assumption. And then say, starting from the second one up to the number that we have, we'll say if controls.preset i.value, best camera, and I'll do this on a separate one actually. So we make a note of the highest or best value we've seen so far, which to begin with is just the first one. And we start with which camera that was, which is the first one. And then starting with the second one, we say if the value is greater than the highest value we've seen, then the best camera is now this camera, and the highest value is this value. And even here I'd be tempted to eliminate the repetition of controls preset i.value. And maybe kind of cheat one fewer lines there. There we go. So this is using a design pattern. When you want to find the best candidate out of a set, you're usually looking for two things that you've got to write. So the start is an assumption that you're then either going to let stand or disprove as you go through the rest of your candidate set. And the second is actually the process of going through. So our starting assumption is we assume that camera 1 is best. Because we've got to start with something. If we
and you would want it to anyways, because like if nobody's talking, you would want it to go back to something, right?
True.
Like if all the values became equal, and that was originally a part of it too. Through nothing but blind luck, it picked whatever would return. It returned a value or an index from whatever table it was that I built. It returned index 1 as a default. So I just used that as my wide shot for the room or whatever.
Okay. Oh, yes. So that's why you had, I noticed you had the first presence pin disconnected.
Yeah, because I knew that it would go back to that no matter what. And I just discovered that through while I was working with trying to figure it out.
Yeah, cool. So we could, I think that works just as well. Just leave the first pin disconnected. We could, if we wanted to, build this module in a way that we're going to hand it off to someone else, we could build it in such a way that you had one more preset than the number of present pins. Mm-hmm. And then we could say that the best camera value was for example, if we have 9 present, it would be our 10th camera. And our highest value here would just be 0. And then anything better than 0 would replace that.
Right.
Yeah, but for now we can default to that first camera, and then we say sort of check every other camera, and if it's better, you use that instead.
That makes sense.
So this pattern you can use over and over again whenever you've got a set of candidates that you want to find the best one of, regardless of whether it's maximum or whatever criteria you might have. The other place you'll see a very similar pattern is if you want to check a whole set of things to be true, for example, if you want to make sure that they all satisfy a certain condition, you can start by your assumption being that they all are true. And then in your loop, you go through and you say, well, if any of them are false, then set our assumption variable to be false, because it doesn't matter how many of them are false. As long as there's more than one, it'll be set to false. So you can reuse that pattern of assumption and then checking to get a result in lots of different cases.
That's really neat.
We've got the same code as before, where we just say light up the LED if the preset we're currently looping through equals the number of the best camera. So we'll turn that on and check that that works. So after 4 seconds, we should get the first preset, and then the fourth preset. Oh, yeah, sorry, it's not the preset value at all. It's cam values I. This is the perks of Zoom before coffee.
Or well after bedtime.
Yes, yeah. Yeah, sorry. So we were comparing that to the value of the preset LED. So the behavior makes sense in that it was comparing each of these preset LEDs values, which was 0,
right,
to the first one, which was 1, and so they all lost all the time. All right, so we'll try that again. So building up number 1, we have a nil with number. On line 52, val and highest value. Because I doesn't exist here, we just want the first one. So building up the first one again, 2, 4, 7, 9. Go to the second one, and as they cross over and the timer runs again, it switches to the second one. And then defaults back to the first one.
It's perfect.
Cool. All right, so we'll take out that print statement. The last thing I was going to ask about is the controls enable being false and then only starting the timer when it turns on. Was that part of the intended use of the room, that the auto switching turns off with a design reboot? Or
I will be honest with you that I do not completely remember why I did that, but there was some sort of reason why I wanted it off unless you intentionally went to turn it on.
Sure.
But it was 2 months ago and I can't remember what that was.
Fair enough. I might be tempted to say, because this is another kind of pattern, we could say essentially the same logic, and I think it makes sense to sometimes to write things out verbosely first. So we could say if when the script starts, enable is on, then start the timer. Otherwise, we don't really need the stop, but we'll leave it there for now because we're about to tweak this. And then when the button changes, we'll do the same thing. You'll see immediately the repetition. The reason we can't just call this function is because it doesn't have a name. So we can say function enable checker, maybe, and then say controls.enable.eventhandler is the enable checker, and we'll just call it when the script starts. And what this will do is make sure that the timer runs as long as enable is on. I'm just making sure that is the case. So just put a little flag in there to check that that timer is indeed running. Yep. And we'll turn it off, and presumably it will stop. Yep, turn it back on. And we get another one. Cool, so that's definitely working. So this is a similar pattern you'll probably use again and again when you want to tie a bit of Lua logic to a control. Define a function that doesn't take any parameters, that just checks the value of the control, executes some logic, and then call it when the script starts and attach it to the event handlers of whichever controls affect it.
Yeah, and the more that we talk about this, I think that the reason that I did that is because it wouldn't actually start the timer unless I actually hit the button to enable it.
Yeah.
The way it was originally written.
Yeah. So if you didn't have that enabled to false and you just started the script with only the event handler attached, then yeah, it wouldn't do anything.
Wouldn't do anything because it didn't. No event was handled.
Exactly. Yeah. So by pulling that function out to be separate and then calling it when we start, we no longer require the event for the initial run of that function, and then only track the changes. So if you did have a site where you did want this to turn off periodically, then I would set it as like a room shutdown snapshot with that off or something like that.
Got it.
Yeah. So that's yeah. I'm cheating by removing a comment, but we could call that 80 lines.
And it was probably 280 before, maybe more.
Possibly, but I think the bulk of that is just eliminating repetition with for loops.
Right.
And that, yeah, it saves a lot. The other neat thing is you'll notice that nowhere in this script do we have 9 copies of anything or even the number 9 appear anywhere. So we could just hit edit on this. Sorry, not edit. Oh no, it is. Yeah, edit on that text controller. And I'm mixing it up, the script with the roles. On that text controller, we could add more present controls and more preset controls and not need to change the code at all. So we could have 9 or we could have 48.
Yeah, and I think even when I got into this scenario, I decided I needed one more preset and had to spend, or one more preset or present light and whatever, and had to spend, a not insignificant amount of time figuring out how to add that really quickly,
Yeah.
This is really cool. I mean, it's that was a lot. There was a lot coming at me fast, but this was really interesting as far as how to take what I would call brute force programming, what I did before, and turn it into something that's significantly more elegant and scalable for sure.
Well, I think a lot of it is just about learning the patterns of it.
Sure.
So you just you see code and you go, oh, that kind of looks like this kind of logic, or even just looking at it, you can kind of see the shape of the code even without looking too closely at the detail of the code, and it starts setting off little triggers thinking, and maybe we can use this function.
Sure.
Yeah, so obviously this is recorded and I can send you a copy so you can review things if that is interesting. But
oh yeah, for sure. And I assume you're gonna do something with it, right?
Yes, so I'm hoping to put it up on our YouTube channel and post it in the Facebook groups, and hopefully get this as a bit of a regular thing with different people who want to discuss their code or cover different concepts, and yeah, try and build up that kind of learning resource, because I think it's really difficult to build a curriculum that works for everyone for this stuff. But working directly with people on their problems, I'm hoping that people will start to see problems that they've faced as well in those activities. So
yeah, for sure. I would say that the most difficult transition that I had was moving away from the block controller. That was a big one for me, that I was just like, and actually it was the beginning of this year that I just said, I have to learn this. I need to figure this out. So I just said no more block controller in January this year, or whatever it was. And it was a tough transition, but man, every time I turn around, every project I work on, I learned some new cute little trick to be able to do something that I did that took me 1,000 years to do before, that takes me 5 minutes to do now.
yes.
It's just it's incredibly powerful what you can do, but it's coming from the background of just a live event audio nerd. It's there's quite a quite a lot to be able to absorb.
Yeah. There's it's sort of borrowing a whole other chunk of industry, really. I mean, people talk about the AV-IT convergence, but it's you get this huge technological leap that comes with quite a learning curve built in if you're trying to leverage the low-level stuff like programming and so on directly.
Yeah, it's as much, if not more. In fact, it is more than going from not knowing what a switch port meant to being able to deal with QoS and IGMP and stuff like that. I mean, that was a huge transition too, and then going through it sort of again with this. But it's so powerful, and there's so much cool stuff you can do.
Yeah. Was there anything else you wanted to cover in terms of Lua coding or things you'd run into? Or...
Not particularly. I mean, to be honest, I'd like to spend some time sort of just kind of thinking about the changes that we made here, and I don't see any functional difference between what it was before and what it is now. It's just incredibly more efficient, I would say, right? Like, there's not, in your opinion, and I'm not trying to say what I did was great or whatever, and I know we don't know each other that well, but I'm just trying to. Was there any concern about deploying it the way it was before?
No, I don't think so. I think sometimes in these kind of code review things, or when people are looking at each other's code or talking about the best ways of doing things with Lua, there's a few different factors, and so one of them is just readability, which, if it works, doesn't matter so much unless I mean, at some point, all software has to be maintained, but if it works, right, it works. There isn't really any argument with that point. Some people talk about the efficiency of the code as well. Like, maybe you should have a table of lookup values rather than calling a function to calculate them every time you need to use them, for example. And for the most part, in a Q-SYS environment, it just doesn't matter, because everything we're doing is such simple logic that it zips through our script before the rest of the system's even noticed. There are some exceptions to that. So some of the stuff that Callum over in New Zealand's doing with the big one was generating QR codes. There you're getting into image manipulation and things that actually do require a lot of cycles, and you're having to optimize quite a bit there. Also, with the only time I've had to do much optimization is with my ArtNet transmission script. In that one, there's a Lua function. I'll come offline here for a sec. There's a Lua function string.char. I can probably just describe it actually, which, as you might know, takes a character like A or B and returns the numerical result. So the string.char or string.byte, each one goes the other way. And calling that function for every byte in the DMX universe that we were sending slowed it down quite a bit. So if we just took every possible value from 0 to 255 and pre-calculated those and stored them in a table and just referenced that table, that was the difference between being able to run like 4 universes of ArtNet at 1% script load and being able to run like 128 universes of ArtNet at 1% script load, just with that change. So there are some times where it comes up, but for the most part, things like this, efficiency of the code really doesn't matter. So it's maintainability, how well you can read it, scalability, if you want to change the number of controls and so on, how difficult that is to do, and then kind of efficiency last. Those are the main concerns with code quality. So I think your code before, it was pretty readable. Like, you could go through and see, well, this is what this function's doing, and this is just another copy of the same logic, and so on. It's not as maintainable in that if you find an issue with the logic, you've got to change it in 9 places, but 9 isn't the end of the world either. And it's not as scalable as it could be because you have to copy paste those functions to resize the number of controls you're using. But those are the only issues, really. I don't have any concerns about efficiency or reliability because the logic is exactly the same as what we've done here, really.
That's awesome.